Okay folks, welcome along to the 2013 higher level question C2. Okay, so it's a hyperbolic paraboloid surface again. It's a uplighter, and it's the surface of the hyperbolic paraboloid is generated by translating the parabola ABC. Okay, which should be fairly straightforward for you to draw now. I'll go through it in a second just in case, but I've drawn most of the drawing to save time. You draw that and you translate it down through this half of a parabola, BD. Okay, now how do you find BD? Good question. We've got a parabola ABC drawn in plan here. Okay, so the parabola in plan, I'll just fix my light here, see if I can get a bit more light. Yeah. The parabola in plan is drawn by simply drawing the rectangle. Okay, so looking at the dimensions here, our rectangle in the drawing, it's 300 obviously, but with scale 1 it's to 2, so that's 150, and that there is 90. All I did was I divided this with 75, and I divided up into 5. This is 90, and I divided up into 5 equal parts. I actually did it with a ruler. I think this is 18s, and this is 15s. So 18, 36, and so on and so forth, and 15, 30, 45, 60. And all you do is just draw your vertical lines. Okay, and then these side divisions join back to the apex, or the vertex I should say, and then you get your parabola points, bring them across over here. You need these lines over here as well. You normally don't draw them, but we draw them. We need them for what I'll go to do in a few minutes. Okay, so that'll get you that curve. How do you find this one here? Well, if you look up here, V1 and V2, okay, they're said to be 90 apart. All right, sorry, 90 here and 90 here. On your drawing, that's 45 and 90 in total. So there's the 90 apart, okay? And they're brought down. And when you translate this curve down, okay, you end up with D here. So the D is wherever the point B here gets brought inwards when it reaches the bottom. So the width here, if you bring it to here, this is the width of 90. So this section of the curve here basically gets copied up here. Okay, and if it gets copied up here, well then the distance between here and here is actually the distance that ends up there. So if you take that distance and it gets translated down, that's it there, B to whatever that is, okay, the new B, I suppose, and that's it actually there. So that's how you find D. It's from here to here, so same distance as this line 2 hits the parabola, okay? So this is being translated out, and we use that information actually to translate the entire curve, okay? So it's literally taking the distance from there to 2, okay, and then marking it off here on the points in the curve, 1, 2, and then that's that there. Then you go off here, okay, then you go up here, and then you go up there, and that's it. So it's basically just a copy of the curve. Once you have those points then, okay, you just draw another smooth curve, as smooth as you can. Okay, that's going to end up in a point now. I'll get my head out the way. Down this way. Okay, as smooth as you can through those points. See how I missed a point there, that's why that's off slightly. I made it worse. There. Gotta redo it. Okay, there we go. Okay, so that's your two parabolic curve. Right? We are going to straighten the drawing. Okay, we're going to straighten the drawing and finish the drawing. That was my young fella coming in there to see what I was doing. Now, right, so drawing this curve then, once you have D, you've got a rectangle. What I did there was this height was 80, so I divided into 5 again, so those are 16s, jumps to 16. And then I just took the distance from here to here, which I think was like 57 or something like that. I set my line off, I did 5 equal divisions of 10, I think, and then I joined the last one back, and these parallel, and that gives me this divided into 5, and I just drew the parabola the exact same way. These join back to the vertex, and these are horizontal lines, and that gets me 4 points here, and I just draw my parabolic curve there. So that gets you the basic setup. The hardest part is getting from here up to here, these curves, okay? You may think you can just redraw another parabolic curve, but it's not the case, okay? If that was the case, it'd be far too easy. So what you have to do is we're going to have to take these lengths here, okay? Each of these lengths is a length when this is hitting here, okay? It translates to a width that we can use, sorry, a point that we'll get on the curve here, okay? And that will actually give us our points up here. All right, so let's start with the this one here, okay? So if we take, so we're using horizontal sections in the end view here. This is the end view. End view, this is the elevation. And this is the plan. Right, so we're going to use the end view and the plan together to get our curve here, this curve that comes along from here to here. Okay, so let's take it here. Let's take the first height here. Okay. So if I take that width from the back of the object to the part where it hits the curve here, okay, and I take it from the back here on the plan to here, okay, so that gives me a point down here. Okay, to check my solution now. Yeah, that looks right. Okay, no, is that right? Oh, I went the wrong way. Sorry, yeah, this width is correct, okay, but I should be marking it from the front there, yeah. So it's from the front, so I'm basically taking my compass and I'm kind of, so wherever I put my compass here, I'm putting it here to show the difference in distance, okay. So that gets me that there, all right. What that point, right, let's just call this point P, P, Q, Q, R, R, S, S, okay, so these lines are P, P, Q, Q, R, R, and S, S, right, so P, P, well, the line will always start here, so P will be there, but P is here, okay, that gives me a width, so if I take that across to both sides, I bring it up, I bring it back up to this line P, that gets me a point here, and here. Okay. So there, P is I call that P, call that P, right? That gives me a point there. If I do the exact same thing for Q, so I take my width here, whatever length this line QQ is, okay, take that, and I bring it back down to B, and I mark it off on B. Yeah, that's where it goes. All right. So that now is Q. So the length here from the tip, from the apex of the curve keeps moving, the vertex keeps moving, B keeps moving down here. So B becomes P, becomes Q, becomes R, becomes S, then it becomes D. And there's D. Okay. But what I'm doing is I'm taking the length and I'm getting a width at each time. Okay. So Q now widens out here to hit the parabola, either side, so wherever to hit the parabola and plan, excuse me, compass in my mouth, I bring it up and onto the line for Q. And also over on the other side, so it's a symmetrical object, so we just do it on each side. So there's your Q's, there's your Q, the widths for Q. I shouldn't really be marking those letters, but anyway. R then, same job. Okay, R. Again, always taking it from B. There's your width R. This one, this line, not needed. R there has its widths, okay. So I just transfer that out to the parabola on either side. Where it hits the parabola, bring it back up, and where it hit the line from R. There. On this side. R. Okay, 9 minutes, not too bad. R. And S then is a very short distance, okay. So there, SS, okay. And there it is. Oop. Rather hastily marked. Okay. You won't have a problem of having to make a YouTube video in your exam, so you won't be rushing through the drawing. And there you go. There you go. There you go. And there's S. And S, and again, it's just a case of joining your lines down through there and there. And that is your there. Okay. And that's your hyperbolic paraboloid in. So that is how you get those curves. Okay, now the final part of the question asks for, go back up now and read it. The final part, so draw the given plan, done, project an in view, done, an elevation, right? Front elevation, completed. The curves in the elevation form a portion of a double hyperbola, okay, whose vertices are V1 and V2 and whose focal points are located at F1 and F2. Now you could have drawn it as a separate double hyperbola, but that's a quicker way of doing it. Determine the asymptotes in the double hyperbola in the elevation. Right, so very, very quickly. This line here, this point O here, and I said going out to V1 and V2 and the F1 and F2 here, right? This line in a double hyperbola is called the transverse axis, okay? So the point from O here to V1 and V2, the transverse axis, right? Transverse axis in a double hyperbola. If you bring a line straight up above the vertices, okay, and you take a circle drawn from the focal point, okay, focal points from the center. So you need a center of the transverse axis, you need the vertices, a line straight up, and you just draw two arcs. Now what those arcs are, okay, are I think the focal circle or whatever. There's an auxiliary circle that's inside here, but the focal circle or the focal arcs, okay, from the center of the transverse axis, okay. So center O, if you swing an arc from F up to hit this line above V1 and V2, that gives you the asymptotes, okay. Normally we draw them with, and that is tangential to that curve, so that curve meets that at infinity. That's what the asymptotes are, okay. So those two lines there, those, okay. And I think one of you had them marked lovely and neatly. I think that's how you spell it, right? ASYMP. Okay, those are the asymptotes there, those two curves. And that's the question done in 12 minutes. Of course, I had to set it up, so you should be able to get it done within 35 minutes. Okay, so yeah, give that a go and load it up into the Google Drive. Thanks, folks.